We're going to use the actual definition of the Maclaurin series to create a series for this, natural log of 2x plus 1. The idea is you take the function, substitute in 0. Take the derivative, substitute 0. Take the second derivative, substitute 0, etc. And then these are going to help give us the coefficients for our power series. So you say f of x is going to be, you substitute 0, and then take the derivative, substitute 0, and then that's going to be the coefficient for x. Then take the second derivative, substitute 0, and for this one, divide by 2 factorial. That's the coefficient for x squared. And then one more, take the third derivative, substitute 0, divide by 3 factorial. That'll be the coefficient for x cubed. And then, of course, it keeps going on forever. So we have, for this function, we've got natural log of 2x plus 1. So you need to substitute a 0 in there. So that's going to be the natural log of 1, which is 0. That's easy enough. Now we need the derivative. So the derivative of this will be 1 over 2x plus 1, but then multiply that by a 2. And then substitute 0. So when x equals 0, this is going to be a 2 over 1. Then we need the second derivative. So you could rewrite this as a 2x plus 1 raised to a negative 1. Bring the negative 1 in front and multiply, so we're going to have a negative in there. Then subtract 1 from the exponent, so that's to the negative 2. An exponent of negative 2 means that the denominator is squared or inverted. There's also the chain rule. You'll need to take the derivative of the inside and multiply. Alright, now substitute x equals 0, which means this is just going to be 1 squared, so then this one becomes negative 4. So let's see, for the third derivative, so I could rewrite the second derivative as negative 4, and then 2x plus 1 is to the negative 3. So the third derivative will then be a positive 12, and 2x plus 1 is now to the negative 4. And then if x equals 0, this is going to be just a 1, so it's 12. Actually, having it in this form makes it easy to take the derivative. So then the fourth derivative is going to be negative 48, and then 2x plus 1 is to the negative 5. When x equals 0, that's going to be just negative 48. Notice how they're alternating? Because alternating series quite often converge. And then we would have positive 240. Now it's to the negative 6, so that's going to be 240. Okay, so then our series is going to look like, first term is 0, so the natural log of 2x plus 1, and it's going to be a 0 for the first term, and then it's a 2 times x. For the second derivative, it has to be divided by 2 factorial, so a 4 divided by a 2, that's going to be negative 2, and that's for x squared. And then we've got a 12 for the third derivative, divided by 3 factorial, so this is 3 times 2 times 1, so that's a 6. A 12 divided by a 6, it's 2. Interesting pattern so far. They're all 2's, but alternating. Let's see if it works. So then we would have 48 divided by 4 factorial, so negative 48 divided by 4 times 3 times 2 times 1 Well, that would be 12 times 2 is 24. It worked again. Negative 2x to the 4th. And then for the x to the 5th, for the 5th derivative, we have 240. And then that's divided by, since that's the 5th derivative, it's divided by 5 factorial, so 5 times 4 times 3 times 2 times 1. So that's a 20 times a 6 is 120, so it's a 2 again. I need to move this over just a bit. So then it's plus 2x to the 5th, and then it goes forever. So it seems that the answer is that it's just an alternating 2, and then you have x to the different powers. Let's test it and see if it works. Like, instead of using 0, use something close to 0. We'll use a half. So try with x equals a half. So substitute a half in, and this is going to be the natural log of 2. Happen to know the natural log of 2 is 0.693. And then I'm wondering, does this work? So substitute a half. So you've put a half in here. That's going to be a half of 2 is 1. A half squared would be 1/4. So that makes it 1/2. Plus this would be a half cubed is 1/8. Together with this would be 1/4. And then this one would be 1/16. So this one would be negative 1/8. And then I can see the pattern down here. The next one's going to be 1/16, 1/32, etc. So does it work? So just to verify, the natural log of 2 is 0.693, so that's when you substitute a half on this side. And then is this a good estimate for that? So 1 minus a half plus 1/4 minus 1/8 plus 1/16. That's a pretty good estimate, considering we're only using 5 terms. So in general, we would have the natural log of 2x plus 1 is equal to the sum of, well, it's alternating, so negative 1 to the n, and then it's going to be just 2's, so just 2's, and then x is to the n power, and from here we have n starting at 1. 1 to infinity. Now the only problem is that this, if you substitute a 1, it's going to start with a negative. It doesn't. So what you can do is just say plus 1, and then when you substitute a 1, it's going to have negative 1 squared, so that's going to start off with a positive, and then it'll alternate from there on.